Homework 6 is dividing polynomials. So we've got sort of 3 different methods that we worked with in this set of notes. The first method is, in these two, you're using factoring. So basically, it's almost like a simplifying sort of situation where you'd factor down the numerator and then you'd find that one of those factors will cancel what you have in the denominator. So we factor this out. We are looking for x times x to give us x squared. And then these values should be multiplying to a negative 84, and then they should be adding up to a positive 8. Okay, so this is almost like a sneaky little thing. Like, you can assume that one of these is going to be x minus 6. Okay, so if this is 6, 6 times what would end up giving you this negative 84, and that's one you might have to play around with a little bit, but it ends up being 14. Okay, so 6 times 14 gives you the negative 84. And if I have a negative 6 and a positive 14, when you add those together, you end up with 8. All right, and then our denominator is x minus 6, so these end up canceling, and my value for this division would just be x plus 14. Okay, so those ones are a little bit more straightforward. They're based off of factoring. These ones, you can use either long or synthetic division. So I want to make sure that you're practicing a little bit of each, so don't stick with one method the entire time. So I'm going to do both 3 and 4. I will do 3 using, let's say, long division. So we set this up. So you've got your first piece right here, and then you are dividing that by n plus 5. So remember the way this works, you focus all of your energy on this first part of the binomial right here, and the second half will just kind of follow along in its place. So we are looking for n times what gives me n squared. Okay, so n times what gives me n squared, and that would be another n. So n times n gives me n squared. We subtract, set up our parentheses, and then you distribute this n to this n plus 5. So when you distribute n to n plus 5, we end up with n squared plus 5n. And then we subtract. And be really careful with the subtraction that you're not messing up any of your signs. So when I subtract, these will cancel, and then I have 11n minus 5n, which is 6n. And then bring down the next term in line and repeat that process until you run out of actual variables and you just have a constant left. So same process, n times what gives us 6n. So n times what gives us 6n, and that would be a positive 6. So you put a positive 6 up here, subtract, set up your parentheses, and then you distribute the 6 to the n plus 5. So when you distribute 6 to n plus 5, you end up with this, which we then subtract. And again, we're going to be very careful with our subtraction so we don't mess up any signs. 25 minus 30 will give us negative 5. So that's when you know you're done, is when you reach the point you just have a constant like that. All right, so your answer is whatever you have up above the division. So we have n plus 6, and then this remainder over this divisor. Okay, so since it's a negative 5, I'm going to write minus, and then you put 5 over the divisor, which is n plus 5. And that would be your answer for number 3. And for number 4, we're going to do synthetic division. So what you do is you take whatever this value is, except the opposite. So if I have a y minus 7, I'm going to take the 7, I'm going to set it up right here. Okay, and then I'm going to separate out my division like this. And then I take these constants, make sure you're careful with the actual sign. So 1y squared, negative 3y, negative 20. One thing you have to be really careful of, both with this method and with this method, is if there's anything missing. Like if you have your initial value right here in standard form, but it's missing something, say it jumps right from a y cubed to a y, or from a y squared to a constant or something like that, you have to include a 0 as a placeholder. So if this is my y squared, this should be my y, this should be my constant. If any of those are missing beyond the first term, you have to put a 0 as a placeholder, or it'll have a domino effect and ruin the rest of the problem. All right, so we set it up like this. This value goes straight down underneath like this. And then what you're going to do is take this value right here, multiply it by the number that's up here, and once you multiply it, that is the value that's going to go in that spot right there. Okay, next step is to take these two values and combine them up. So when I combine them up, I get 4. And then you just repeat that process until you run out of space. All right, so this value right here gets multiplied by this value right here, which then gets written in the next spot. And then once again, you combine these two values and put it in the empty spot down here. And now we're out of values, which means our problem is done. All right, so this, I like to go from right to left when I'm filling these values in. So the last number right here is always the remainder. So we write 8 over the divisor, just like we wrote -5 over the n plus 5. So we put 8 over the divisor, which is y minus 7. And so if this is the remainder, that means the number before is the constant, the number 4 is the first degree, and then you just keep moving like that. So before the 8 is a 4, so that means that the 4 is our constant, and before the 4 is a 1, so the 1 is the y term. Okay, or whatever variable you have, x or q, anything. All right, so this is our final answer.